Here we have the alternating series of negative 1 to the n times n squared plus 3 divided by n to the third. And we want to show that this series converges using the alternating series test. And so recall that we want to use the alternating series test to show that the series converges. We have to show two things. We have to show that the limit of base of n as n approaches infinity is 0, and then we have to show that the a sub n is a decreasing sequence, meaning a sub n is larger than a sub n plus 1, larger than a sub n plus 2, and so on. And so first we will show that the limit of a sub n is equal to 0 as n approaches infinity, and then we will show that the sequence a sub n is decreasing. And so the limit of a sub n this is equal to this. And to find this limit right here, we can divide everything top and bottom by n to the third. So divide everything on the top by n to the third, divide everything on the bottom by n to the third. N to the second divided by n to the third is 1 over n, and then n to the third divided by n to the third is 1. As n approaches infinity, 1 over n will go to 0, and then 3 over n squared will also go to 0, so we get 0, this is 0. And so we have shown that the alternating series, we've shown that the limit of base of n is equal to 0, and now we need to show that the sequence a sub n here is a decreasing sequence. And so for one like this, it's difficult to do a direct comparison, meaning if we form a sub n plus 1. So we form a sub n plus 1, and in the place of n, we would have n plus 1. And so this is going to be difficult to compare this with this. And that's what we have to show. We have to show that a sub n is greater than or equal to a sub n plus 1, meaning we have to show that this sequence right here is decreasing. And since we cannot do a direct comparison, what we can do is go to the first derivative. And so right here, the corresponding function, the corresponding continuous function is x squared plus 3 divided by x to the third. And then we have to show that the corresponding function is decreasing. And so we just need to show that this function right here is decreasing, and then we can say that this sequence is decreasing. And one way to show that a function is decreasing is by showing that the derivative is negative. And recall that here we're dealing with n greater than or equal to 1. And so here we're also dealing with x greater than or equal to 1. And so to show that f of x is decreasing, we need to show that f prime of x, or the derivative, is negative or less than 0 for x greater than or equal to 1. And so that's how we show that a function is decreasing, by showing that the derivative is negative. And so let's do the derivative of this function right here. And this is a quotient, so we need to use the quotient rule. So it would be x to the third times the derivative of x squared plus 3, and then minus x squared plus 3, and then times the derivative of x to the third, and then divided by x to the third square. And that's the quotient rule. The derivative of x squared plus 3 be just 2x. The derivative of x to the third is 3x squared. And then x to the third square is just x to the 6. And this becomes 2x to the fourth. And then we have a negative here, so let's go ahead and move this to the front here so we can multiply. Negative 3x squared times x squared, that would be negative 3x to the fourth. And then negative 3x squared minus times 3 be negative 9x squared. And then 2x to the fourth minus 3x to the fourth is minus 1x to the fourth. And this will always be negative, because this is the x to the 6 is always going to be positive, and then the negative 1x to the fourth be negative, the negative 9x to the negative 9x squared will also be negative. And so the top will always be negative, the bottom will always be positive, and therefore this quotient is always will be negative for x greater than or equal to 1. And hence we have shown that the ace of bend right here is a decreasing sequence and we can also see here in the spreadsheet, this is Google spreadsheet, and this is n, and this is n squared plus 3 divided by n to the third, and then we can see that the sequence is decreasing here. The numbers, the values, they're getting smaller. And so, in summary, if we want to compare a sub n plus a sub n plus 1, if we cannot compare them directly, then the alternative would be to show that the derivative is negative for x greater than or equal to 1. Then we can show that then that's the other way, and that's how we show that the sequence is decreasing.